Hello everyone. Hello everyone. Welcome to Wallah. So we are starting transmission line. We are discussing the transmission line topic. So today we are going to discuss impedance. Impedance means quarter wavelength impedance, lambda by 8 impedance. So input impedance for different length of the transmission line. And second, what we are going to discuss, a reflection coefficient. We are going to discuss a reflection coefficient. Tomorrow we will going to discuss question discussion regarding this impedance and reflection coefficient. So today we will study only this part, a reflection coefficient. Okay, so these are the two topics which we are going to discuss today. So yesterday we have done question discussion. This is recap now. So yesterday we have done question discussion. Today we will do impedance and reflection coefficient. Reflection coefficient. Okay, so first of all we will go through the impedance. So first of all they will ask, what is the input impedance for short circuited transmission line? What is the input impedance for what is the input impedance for open circuited transmission line? I have taught this topic. I have taught series resonance, I have taught parallel resonance. So these all topics I have taught. Then after I will taught today impedance. Impedance means I am going to teach you what is the impedance, normalized impedance, what is the input impedance for quarter wavelength, what is the input impedance for half wavelength, and what is the input impedance for that lambda by 8 wavelength. So any length, any arbitrary length, what we will do. So this is the topics very important regarding the question or regarding the important for GATE exam also. So it is very important. So this is input impedance. Hello John Wick. Input impedance. First one is when length of the transmission line is lambda by 8. When length of the transmission line is lambda by 8. So this is our transmission line. This is our transmission line. This is only one transmission line. First one is inner conductor, second one is outer conductor, and this is our load ZL, and the length of the transmission line is lambda by 8. So at this lambda by 8, what is the value of input impedance? So first of all we are going to discuss input impedance. So we have to calculate first of all electrical length. What we are going to discuss? Electrical length. Electrical length is important. according to electrical length, the formula for input impedance changes. So beta L 2 pi by lambda and length is lambda by 8, so it is pi by 4. So our tan beta L will be equal to pi by 4. So I will use the input impedance formula for short circuited transmission line. I will use the input impedance formula for lambda by 8 transmission line. So Z0 lossless transmission line. So ZL JZ0 tan beta L. This is the input impedance formula for lossless transmission line. ZL tan beta L. If it is not lossless, then it will be hyperbolic L. It's already started, John Wick. Get 2024-25. You can go through and check in the PW website, or you can just also call the customer care. It's already started, I think so, in electric and in English batch. So this is the this is a sample video. So how can we teach in the paid classes? Okay, so this is ZL plus JZ0, and at length lambda by 8, beta L will be pi by 4. At length lambda by 8, beta L will be pi by 4, and pi by tan beta L will pi by 4 is equal to tan pi by 4 is equal to 1. Sorry for that. Tan pi by 4 is equal to 1. So Z0 plus JZL. It is very important formula for length. Which length? Length lambda by 8. You should remember this formula. It is very important. It is very important for us. Okay. Then after we have second length. Second length is lambda by 4. Second length is our lambda by 4. You can pause the video and write it down. I will go for next point. So second term is L is equal to lambda by 2. In that case beta L will be equal to 2 pi by lambda into lambda by 4. So it will be how much? It will be how much? Pi by 2. It will be how much? Pi by 2. So this one is pi by 2. Then the length, this length is known as quarter wavelength length. This length is known as quarter wavelength length. So this is quarter wavelength length. I will write it down like this also. Sorry for that. 2n plus 1 lambda by 4. It will be 3 lambda by 4, 5 lambda by 4, 7 lambda by 4 and 9 lambda by 4, like that. So it is 2n plus 1 lambda by 4. So beta L will be equal to, electrical length will be equal to 2 pi by lambda into odd multiple of lambda by 4. So what it will be? It will be odd multiple of pi by 4. Odd multiple of pi by 4. Yes sir, pi by 2. Odd multiple of pi by 2. So this is the length. This length is known as quarter wavelength transmission line. This length is known as quarter wavelength transmission line. So in GATE exam or in any exam, the length is written in terms of language, that is quarter wavelength. So quarter wavelength is odd multiple of lambda by 4 or lambda by 4. Then after, the formula for Zin will be equal to, for lossless transmission line, Z0 plus ZZ0 tan beta L and divided by Z0 Z0 plus JZL tan beta L. But at pi by 2, 3 pi by 2, tan beta L is infinity, so the ratio will be infinity by infinity. If I will put beta L is equal to pi by 2, then it will be infinity, and this one is also infinity, so it will be infinity by infinity, so we cannot get the value. So I will take the limit. How we will take limit? So I will divide by infinity. So this one is ZL by tan beta L and plus JZ naught, and second one is ZN Z naught by tan beta L and JZL. And what we will put, I will put beta L will be equal to odd multiple of pi by 2. In the case of odd multiple of pi by 2, this one will become 0 and this one will also become 0. So our input impedance will be equal to JZ naught upon JZL. That means Z naught square upon ZL. This is the formula for input impedance for quarter wavelength transmission line. So input impedance for quarter wavelength transmission line is odd multiple of lambda by 4 is equal to Z naught square upon ZL. Z naught square upon ZL. So this is known as quarter wavelength transmission line. Then we have a length 3 lambda by 8. Then we have a length 3 lambda by 8. So you can pause the video and write it down. I will go through the next point. So third point is length is 3 lambda by 8. So again you have to calculate beta L. Because you will calculate beta L, you will get the value. If you will not calculate the beta L, you will not get the value. So you have to calculate beta L. So that means we 3 pi by 4 and the length of the transmission line is 3 lambda by 8. So they may be give length lambda by 4, they may be give length lambda by 8 like that. So 3 lambda by 4. This is our length 3 lambda by 8. Yes. Then after we will apply the formula for input impedance in lossless transmission line Z0 ZL plus JZ0 tan beta L. The basic formula for input impedance is this one only, but we will put beta L value and we will get different formula. So I will put beta L is equal to tan 3 pi by 4, and in that case tan 3 pi by 4 is equal to minus 1, tan 3 pi by 4 is equal to minus 1. So we have Z in at 3 lambda by 8 is equal to the what Z0 ZL minus JZ0 divided by Z0 minus JZL. Yes sir. So this is the formula for our Zn. This is the formula for Zn. So this is formula for which length? 3 lambda by 8. Then we have one length also, one length remaining lambda by 2 at lambda by 2. So what will happen at lambda by 2? Lambda by 2 is 3 lambda by 2. That means our beta L will be equal to 2 pi by lambda into lambda by 2. So it will be pi, and tan pi is equal to, so tan beta L will be equal to tan pi, and tan pi is equal to 0. So our Zn will be equal to, we will see. So this is our length of the transmission line, this is our ZL, and this is Zn. Length is lambda by 2, n lambda by 2 you can take n lambda by 2. So n pi, and n pi is equal to 0, tan n pi is equal to 0. So tan n pi is equal to 0. So our length is n lambda by 2, half wavelength. This one is known as half wavelength. So formula for Zn is Zn Z0 ZL plus JZ0 tan beta L. Tan beta L is how much? 0. Z0 plus JZL tan beta L. Tan beta L is 0. So beta L is equal to n pi. So tan n pi is equal to 0. So you will get Zn at length n lambda by 2. What you will get? You will get Z0 ZL plus J0 0 Z0 plus J0. So Z0 will be cancelled out. Our Zin will be equal to ZL. Zin will be equal to ZL. So this is our length at length N lambda by 2. So we have calculated different length transmission line formula or input impedance. This type of question is asked in GATE 2024. In GATE 2024. Okay. So what we have studied we have studied different length formula. This is our transmission line. So one more question, one more point, then we will discuss this. Fifth, normalized impedance. So they may be asked in interview also why we calculate normalized impedance. It is very important in interview purpose also. Why we calculate normalized impedance. So there is a point why we calculate normalized impedance. First of all, the range of ZL. Let us assume the range of ZL. Let us assume the range of the ZL. ZL range will be equal to, it may be 0 ohm to 25,000 ohm. That means 25 kilo ohm. So this is a very big range. This is a very big range. And if Z0 is equal to 50 ohm, okay, so I can say normalized load impedance is equal to, because range is very big, so I will take normalized load impedance. In this case, what will happen? In this case, ZL is upon Z0. That means our range will become 0 ohm to 2500 and 500. Our range will become 500, 0 to 500. So this range will become small. This range will be small. So we can say that the range will reduce because of normalization. Because of normalization, the range is reduced. So we use normalization. So here range is large range. Here large range. And here a small range. Here a small range. So they will ask why normalized impedance we are calculating. So you can say that their range will be reduced. Why it is reduced? You can think it here. Why it is reduced? You can think it here. So it will be 0 to 500. So our normalized input impedance formula. So normalized input impedance. So normalized load impedance is written as, normalized load impedance is written as ZL bar. That means ZL upon Z0. Normalized input impedance will be written as Zin bar. Normalized input impedance will be written as Zin bar. Input impedance is written as Zin bar. Zin bar is equal to Zin upon Z0. So this is the point you can remember. This is the point you can remember. So our normalized impedance is over. Then we take a summary. We take a small look of impedance, because this is very important formula, and all formula are very important. So we take a small look for impedance. Okay, so we will take a summary. We look on the summary. It is very important. So in case of summary, it is very important. You can use the summary, you use the concept of summary, you will get the answer. So first of all, first point is, what is ZSC? So ZSC is equal to ZZ0 tan hyperbolic gamma L. and ZSC is equal to JZ0 tan beta L. So first one is for lossy, second is for lossless. Similarly, Z0 cot beta L, cot hyperbolic gamma L, and similarly for lossless, the open circuit formula will be JZ0 cot beta L, it will be minus also. So this is for lossy, and this is for lossless. This is for lossless. This is also for lossy, and this is for lossless. Yes. Third thing is, you have to remember Z0 is equal to under root ZSC into ZOC. It is for lossy and lossless both. Lossy and lossless both. Yes, sir. Lossy plus lossless. Then we have fourth, for Zin at length lambda by 8. It will be equal to Z0 ZL plus JZ0 divided by Z0 plus JZL. So this is the formula for length. It is complex. It is how thing? It is this input impedance is complex. Then we have length 3 lambda by 8. Then we have length. Which type of length? 3 lambda by 8. At 3 lambda by 8, Zin will be equal to Z0 ZL minus JZ0 divided by Z0 plus minus JZL. So this is the formula for length. Which length? Length 3 lambda by 8. This is the formula for length 3 lambda by 8. So we have to remember this formula. They may be asked question directly. Again 6th point is Zin for length odd multiple of lambda by 4. Odd multiple of lambda by 4. What will be the answer? So odd multiple of lambda by 4, the answer will be Z0 square upon ZL. Z0 square upon ZL. So this is the formula for our input impedance, Z0 square upon ZL. I will take Zin, yes sir, is equal to Z0 square upon ZL, yes sir. I will take Zin by Z0 is equal to Z0 by ZL, yes sir. Zin by Z0 is Zin bar, that means normalized input impedance, and 1 by ZL bar, that means Zin bar is equal to YL bar. Zin bar is equal to YL bar. So what you understand from here? You can understand from here that the input impedance is in normalized load admittance. That means our load impedance will be get inverted. That means if ZL is equal to 0, Zin is equal to infinite. If ZL is equal to infinite, Zin is equal to 0. If ZL is inductive, Zin is capacitive. If ZL is capacitive, Zin is inductive. So our nature is inverted. Because of that, we can say that here input inversion occurs. So we can take this point here. Zin bar is equal to 1 by ZL bar. Zin bar is equal to 1 by ZL bar. If ZL is equal to 0, that means short circuit, then Zin will be equal to infinite. If ZL is equal to infinite, then Zin is equal to 0. Zin is equal to 0. If ZL is equal to capacitive, then Zin will be equal to what? Inductive. So you can think over like this. At which length? At lambda by 4. At which length? At lambda by 4. It will be inductive. Or if Zn is equal to inductive, if Zn is inductive, so ZL is inductive, then Zn is capacitive. Zn is capacitive. So minus J is capacitive, plus J is inductive. Minus J is capacitive, plus J is inductive. Capacitive, inductive, inductive, capacitive. So we are getting impedance inversion. We are getting impedance inversion. You can think over like this. We are getting impedance inversion. That means this one is open circuit, this one will be short circuit. This one is short circuit, this one will be open circuit. This one is inductive, this one will be capacitive. This one will be capacitive, and this one is capacitive. This one should be input impedance should be inductive. So we can say that the nature of impedance is inverted here. The nature of impedance is inverted here. The nature of impedance is inverted here. So we are say that here at length odd multiple of lambda by 4, impedance inversion occurs. Impedance inversion occurs. So we can say that impedance inversion occurs. So this is the point. You can note it down and you can remember. So impedance inversion occurs at length lambda by 4, odd multiple of lambda by 4. Then we have next point. Next point is at 7th point. So at length is equal to n lambda by 2. At length is equal to n lambda by 2. So Zn will be so length is equal to n lambda by 2. Zn will be equal to Z0. So this one is known as, if this one is short circuit, this one is short circuit. This one is open circuit, this one is open circuit. Capacitive, capacitive. Inductive, inductive. So this one is known as image impedance. This one is known as image impedance. Image impedance. The load impedance and input impedance are same. So we can say that it is image impedance. In network theory, there is nothing like this. But in transmission line theory, the nature is changed. Why? Because wave nature of voltage and current. So in network theory you study ZL is equal to Zn is equal to ZL. But in transmission line theory, the nature is changed. The nature is changed. Okay. So in transmission line theory, the nature is changed. So here is our load impedance ZL. Here is our load impedance ZL. If I will say what is the input impedance here, so you will say input impedance will be equal to ZL. If I will say at length lambda by 8, what will be the load impedance? So what will be the input impedance after lambda by 8? So Zn will be changed. So Zn will be changed. I will say what is the length at after lambda by 8, that means lambda by 4, Zn nature will be changed. At length lambda by 8, that means 3 lambda by 4, lambda by 8, the Zn nature will be changed. And at lambda by 2, Zn nature will be changed. So this is the point here. So you can note it down that here Zn will be equal to Z0 ZL plus JZ0 divided by Z0 plus JZL. This is the formula at this point. At this point, Zn will be equal to Z0 square upon ZL. Means our length is lambda by 8, that means lambda by 4. Here length is how much? The here length is our 3 lambda by 8. So it will be Z0, ZL minus JZ0 and Z0 upon Z0 minus JZL. Yes sir. And here Zn will be equal to ZL. So you can note it down. So our nature is repeating. Here ZL, here complex, here inversion, here complex, and here ZL. Then after complex, inversion, complex, ZL. So nature will be repeating after that. ZL, complex, inversion, ZL, and complex and ZL. So after that, what will happen? After that, the Zn will be this one only. After that, inversion. After that, this 3 lambda by 8. After that, this lambda by 2. So answer will be same. Like that, the value will be changing. Like that, the value will be changed. So this is the point here, 8th point. And we have 9th point. 9th point is resonance. When resonance, which type of resonance will occur? When which types of resonance will occur? I have told, I have written also, but in summary I will write it down also. You will remember it again, so it will be very helpful for you. You will remember it again, it will be very helpful for you. So this is for short circuited. Yes sir. Short circuited is JZ0 tan beta L. And this is for open circuited. Open circuited is minus JZ0 cot beta L. Yes sir. Then we have what? We have series resonance. Then we have the short circuitance value is 0 and short circuitance value is infinite. Open circuited value input impedance is 0 and open circuit input impedance is infinite. If it is 0, it is known as series resonance. Okay, this one is known as series resonance. And second one is known as parallel resonance. Series resonance. Second one is parallel resonance. And third one is also series resonance. So you can write it on only series and parallel also, you will understand. So this one is series and second one is parallel. Resonance. Then I will ask, what is the value of length? You can easily tell. Here short circuit is short circuit. Short circuit is short circuit, that means length should be. Load is equal to load. Load is equal to load at length lambda by 2, and load will become inversion. So load inversion will occur at lambda by 4. So here short circuit is short circuit, so length is n lambda by 2, and short circuit will become open circuit, so inversion. So inversion, odd multiple of lambda by 4. Yes sir, odd multiple of lambda by 4. Here open circuit, short circuit, inversion, so odd multiple of lambda by 4. And here image impedance, so it will be n lambda by 2. It will be n lambda by 2. Then we will calculate the value of lambda. Lambda is equal to 12 by n. Lambda is equal to 4L by n, 4L divided by odd multiple, and here lambda is equal to 4L by odd multiple, and here lambda is equal to 12 by n. So this is the formula for lambda. Then we have formula for F naught. F naught is equal to Vp by lambda, so n Vp by 4L, 2L, sorry, n Vp by 2L. So here F naught is n Vp by odd multiple of Vp by divided by 4L, odd multiple of Vp divided by 4L, and here F naught is odd multiple of Vp divided by 4L, and here F naught is n Vp by 2L, n Vp by 2L. Then here n will be 1, 2, 3 from 1, and here n will be 0, 1, 2, 3, and here n will be 0, 1, 2, 3, 0, 1, 2, 3, and here n will be 1, 2, 3, 4, like that. So we have calculated the value of series and parallel resonance we have done. So this is the condition for series and parallel resonance. Then there is also graph. You can write it down in summary graph. So we have drawn the graph in short circuit, so you can go through the graph also. And there is inductive capacitive, inductive capacitive, like that. So you can go through the graph, and inductive capacitive you should know that. Just, and the last thing you have to know, in GATE exam, it will not ask in GATE exam, it may ask in ECE or different PSUs, that what is the value of quality factor. If resonance is there, then there should be quality factor. If resonance is there, then there should be quality factor. What is the value of quality factor? So quality factor is equal to alpha, beta upon 2 alpha, beta upon 2 alpha, and it will be resonant frequency upon bandwidth. So you can find it anything. They will ask alpha, they will ask resonant frequency. So resonant frequency you can calculate it from here, and beta and alpha is given. So you can calculate quality factor, and you know the resonant frequency from here. Then you can calculate the bandwidth. It is very easy. Then you can calculate the bandwidth. It is very easy. So this is, in this way you can calculate the bandwidth. Then we have second last topic, that is our reflection coefficient. Reflection coefficient. What is reflection coefficient? You should know what is a reflection coefficient. Then you can calculate. So reflection coefficient is important. Tomorrow we will discuss some question, and we will start VSWR or power. So our reflection coefficient. First of all, what is the reflection coefficient at different length of the transmission line? First of all, I will discuss for lossless transmission line. Then I will discuss somewhat for lossy transmission line. So first one is for lossless transmission line. This is ZL, and here we can calculate, and the input impedance is here Z0. So first of all we can calculate it here at x is equal to 0. This is x is equal to 0 and this is x is equal to L. Okay, so at x is equal to 0 we can call it as reflection coefficient at load. So this one is known as a reflection coefficient at load, ZL minus Z0 divided by ZL plus Z0. So gamma in L is known as a reflection coefficient at load, reflection coefficient at load. Yes sir. Then we calculate input reflection coefficient. Then we calculate input reflection coefficient. Then we calculate a reflection coefficient at a distance x. So there is 3 formula. So second one is input reflection coefficient, input reflection coefficient, or gamma x is reflection coefficient at a distance x from the load, at a distance x from the load. So gamma x is reflection coefficient at a distance x from the load, Yes, so this is the point, reflection coefficient at load at a distance x from the load and input reflection coefficient. Yes sir. Then we have some formula. First formula is, what is gamma L? Gamma L is equal to ZL minus Z0 divided by ZL plus Z0. Yes sir. This is the formula for gamma L. 1 second. This is the reflection coefficient from the load. Second thing is input reflection coefficient. Input reflection coefficient is a reflection from the load minus e to the power 2 beta L. This is for lossless transmission line. So for lossless transmission line, thank you Ansul. Thank you. Third, thank you very much for your appreciation. So gamma in we have calculated. Gamma x, distance x from the load. Distance x from the load. Gamma L, e to the power minus j 2 beta x. This is the reflection coefficient at distance x from the load. Then we have at this point input impedance Zx, and we have at this point input impedance Zin. So ZL will be equal to, this is a very important formula, so we can apply componendo dividendo 1 plus gamma L 1 minus gamma L into Z0. This is very important formula. Fifth one is you can apply it here. So Zin will be equal to, I will use reflection coefficient input, I will use reflection coefficient input into Z0. And the last one is sixth one, at a distance x, so I will take a reflection coefficient at a distance x, so I will take a reflection coefficient at a distance x from the load. So you can use the input impedance formula here. If you are calculating input impedance here, you will take reflection coefficient of this one, If you are calculating input impedance here, you can take reflection coefficient of gamma x. If you are calculating the input impedance here, you can take reflection coefficient of gamma in. So if you are calculating at ZL, so at load you will take reflection coefficient at load. If you are calculating the thank you Babu. So if you are taking in a reflection coefficient gamma in, so you can calculate Z in, and if you take reflection coefficient gamma x, you can calculate Zx. Thank you Ansul. आप अपने जूनियर से बताओगे. Thank you. Okay, so this is the points you can remember. This is the points you can remember. Then there is one more points. Which point? That means 7th point. ZL is equal to if ZL is complex, and we have Z0. Z0 is equal to R0 for lossless or lossy plus distortionless. Lossless transmission line, Z0 will be R0. Z0 should be R0. So if Z0 is equal to R0 for lossless transmission line, yes sir. So for lossless transmission line, Z0 is R0, and then after we have reflection coefficient gamma L. It is very important formula for VSWR. You can analyze VSWR by knowing this basic thing. So gamma L will be equal to ZL minus Z0, ZL plus Z0. Yes sir. Then we have RL plus JXL minus R0, and then after RL plus JXL plus R0. Yes sir. This one is, you can take RL minus R0. Yes sir. And real part and imaginary part, you can separate it. RL plus R0, you can separate it, plus JXL. Then after I will ask, what is the magnitude of gamma L? What is the magnitude of gamma L? You will say magnitude of gamma L is RL minus R0 whole square, real part square plus imaginary part square, and then after also real part square plus imaginary part square. This is the magnitude by taking under root. So this is the value of our magnitude of gamma L. Then we have theta gamma. It is very important. So theta gamma is imaginary upon real. So tan inverse imaginary upon real, XL upon RL minus R0, and if it is divide minus, then we have imaginary upon real. You know, in complex what we will do for angle calculation. So in angle calculation or argument calculation in complex, you can do imaginary upon real. If it is divide, you can take minus. If they are in multiply, you can take plus. This is the point. So you have calculated gamma and theta gamma. So we can say that our gamma has two things. That is magnitude and angle. So gamma L has two things, magnitude and angle. This is the representation of complex number R e to the power j theta. So here magnitude and here angle. Then we have gamma x. What is the formula of gamma x? Gamma L e to the power minus j 2 beta x. So we can calculate mod gamma L e to the power j theta gamma e to the power j 2 beta x, and this is the basic formula for VSWR. So we are going to discuss in VSWR. This is the basic formula. So gamma L e to the power j minus j 2 beta x minus theta gamma. This is the very important formula for in VSWR. Calculating maxima point, minimum point. This is very important. So this is the formula for gamma x. From gamma x you can conclude one thing. I am going to tell you that conclusion. and then after our reflection coefficient will be over. So in magnitude of gamma x, so gamma x will be equal to magnitude of gamma L e to the power minus j 2 beta x minus theta gamma. Yes sir. Then we have magnitude of gamma x. Magnitude of gamma x is equal to magnitude of gamma L. So VSWR will be equal to 1 plus mod gamma x and 1 minus mod gamma x. Yes sir. So VSWR is same at everywhere. So mod gamma L, it does not depends upon x. So if it is not depending upon x, so we can calculate that VSWR does not depends upon x. VSWR does not depends upon x. VSWR is uniform over the transmission line. This is for lossless transmission line. At here, everywhere VSWR will be same. Everywhere VSWR will be same. But in case of lossy transmission line, what will happen? So this is the question which is not asked in ECE or GATE exam, but they will ask. So in lossy transmission line, what will happen? So in lossy transmission line, what will happen? In lossy transmission line, gamma x will be equal to gamma L e to the power minus 2 gamma L. So gamma L e to the power minus 2 alpha x. I will write x. So it will be 2 alpha x and minus j2 beta x. Yes sir. So I will ask, what is the magnitude of gamma x? So magnitude of gamma x is magnitude of gamma L e to the power minus 2 alpha x. Yes sir. So this is the magnitude of gamma L. So VSWR will be equal to 1 plus mod gamma L e to the power minus 2 alpha x divided by 1 minus mod gamma L e to the power minus 2 alpha x. So if in GATE exam they will ask, only few people will give the answer. So this is the main point, you can write it down. And in this case VSWR will not be uniform. In this case the VSWR will not be uniform. At here VSWR is something else, at here VSWR is something else. So the VSWR value will change at distance, every distance. At every point the VSWR value will change. What is the VSWR? Here VSWR is 1 plus mod gamma L, 1 minus mod gamma L. But here VSWR is 1 plus mod gamma L e to the power minus 2 alpha L divided by 1 minus mod gamma L e to the power minus 2 alpha L. This is the point here. So here a reflection coefficient magnitude is not same. Here reflection coefficient VSWR will not be same. In this case the VSWR value will change according to the length. The VSWR value will change according to the length. So in tomorrow class we will study matching, mismatching, completely matching, completely mismatching, and then after we will discuss some question, and then after, if time remain, then we will discuss VSWR. So this is your power. So this is the things. So we are discussing. I'm stop the class from at this point, and tomorrow we will meet it again. So what we have studied? We have studied impedance. And second thing, we have studied a reflection coefficient. So tomorrow we will discuss some question, 10 to 12 question regarding reflection coefficient, impedance, and many other things. Okay. So and this is the Unity app, you can download. There is very important interactive for 3D model library, live classes, YouTube notification, dashboard, video call. There is so many things are in Unity app, and this is the facilities in Unity app. You can download it from the Google Play Store. This is Sonu Sir PW group, live telegram group. You can use this group for any doubt clearing or any thing you can ask. So this is Sonu Sir PW telegram link, telegram group. You can directly join. Okay, thank you for the class.